In this lesson, we'll be proving that lines are parallel. So the objective is to determine whether two lines are parallel. The postulates and theorems in this lesson are all the converses of the theorems that we had in the last lesson about parallel lines. So remember, a converse switches the hypothesis and the conclusion of a conditional statement. So let's look at these converses. The first one is the corresponding angles postulate converse. So it's going to be the converse of the corresponding angles postulate. It states that if two lines and a transversal form corresponding angles that are congruent, then the lines are going to be parallel. So note here that in the last lesson, with the postulates and theorems that we had, we started out knowing that the lines were parallel. And then we had certain angle relationships that existed because the lines were parallel. This time we're starting with two lines that we don't know they're parallel. You have to prove they're parallel. So that's when you use the converses. It's when you're trying to prove two lines are parallel. So in this particular example, we have two angles that are marked congruent. So the transversal, to look at the transversal, and we have two angles that are congruent. So here we have if angle 2 is congruent to angle 6 and are corresponding angles, then we can say that line L is parallel to line M. And this converse of the corresponding angles postulate is actually used in the proofs for the angle relationships below. So let's look at the ones below. The next converse is the alternate interior angles converse. It states that if two lines in a transversal form alternate interior angles that are congruent, then those two lines are going to be parallel. So once again, look at the transversal and identify the alternate interior angles are identified as congruent. So here we have if angle 4 is congruent to angle 6 and form alternate interior angles, then you can state that L is parallel to line M. In the next one, the same side interior angles converse. If two lines in a transversal form same side interior angles that are supplementary, then you can state that those two lines are parallel. So once again, you have a transversal. You have two angles here, 3 and 6, that are same side interior angles. So we can say if the measure of angle 3 plus the measure of angle 6 is 180, and the angles are same side interior, then we can state that line L is parallel to line M. The last converse we have is the alternate exterior angles converse, which states that if two lines in a transversal form alternate exterior angles that are congruent, then we can make the conclusion that the two lines are parallel. So once again, look at your transversal, and we have two angles. We can say if angle 1 is congruent to angle 7, and the angles are alternate exterior angles, then we can conclude that line L is parallel to line M. The other thing we're going to talk about in this lesson is a flow proof. A flow proof uses arrows to show the logical connections between statements, and then the reasons are written below the statement. So we're going to do that in problem 2. We'll write a flow proof to let you see how that is written. So let's go look at problem 1. In problem 1, we're identifying which lines are parallel if angle 2 is congruent to angle 3. We have to justify our answer, which means we're going to use one of these converses from this lesson as a reason for making that statement. So let's look at angles 2 and 3. And if you look at angles 2 and 3, the first thing you need to do is identify which of these lines, there's 4 lines drawn here, A and B and N and M. So which of those lines would be a transversal in relation to angles 2 and 3? So the transversal line would be A, and then the 2 parallel lines would have to be line N and line M. So N is parallel to M because angle 2 and angle 3 are alternate interior angles, and angle 2 is congruent to angle 3. So by the alternate interior angles converse is how we can justify this. Alternate interior angles converse. Remember, the converse, you only use converse when you're proving lines are parallel. So in problem 2, you're going to write a flow proof to prove that line A is parallel to line B, given measure of angle 5 is 40 and the measure of angle 2 is 140. So a flow proof shows the logical flow of a proof. You put your statements in a box and write the reason for making that statement underneath the box. And so let's look at the given information. It's normally what you start with. So let's put what we're given in a box. We got the measure of angle 5 is equal to 40. That's given. Let's put that in a box and say that that's given. Below that, we're also given that the measure of angle 2 is equal to 140. So we will put that in a box and indicate that that is also given. So what else can we conclude? So what can we conclude from that given information? We know that 40 plus 140 is 180, so that means that those 2 angles are supplementary because the sum is 180. So we can conclude from that, the next statement would be that angle 5 and angle 2 are supplementary angles. So that's the statement we're making. We're going to put it in a box. The reason we can make that is because of the definition of supplementary angles. And that statement came from these first 2 given statements were what led us to make that statement. So we're going to draw arrows to show the flow of those first 2 statements into that statement. The other thing that we can see from the diagram is that angle 5 and angle 2 are same side interior angles. So that's the statement we're making. Put a box around it. And that's just by definition of same side interior angles from the diagram. So based on these two statements that we've made, angles 5 and 2 are supplementary angles and they're same side interior angles, we can make the conclusion that A is parallel to B. So we're going to put that in a box. And each of these statements led to that. So we're going to flow and show the arrows that flow to that from the previous boxes. And the reason we can make the statement that A is parallel to B is because of the same side interior angles converse. Remember, the only time we ever use a converse of one of these theorems or postulates is when we're proving two lines are parallel. So we've just proven that line A is parallel to line B. So we use the converse to do that. In problem 3, we're determining whether lines are parallel. And we are given a diagram, and it says if the measure of angle 1 is 65 degrees and the measure of angle 2 is 115, are lines A and B parallel? And explain that. So let's look at lines 1 and 2 in relation to this line. So this line is the transversal for lines 1 and 2. And we want to determine if A and B are parallel or not. So what kind of angles are angles 1 and 2? From the diagram, we can see that they are same side interior angles. And we also can see that the measure of angle 1, which is 65, plus the measure of angle 2, which is 115, is equal to 180. So that also means that they're supplementary. So the answer is yes, A is parallel to B because angle 1 and angle 2 are same side interior angles and are supplementary. So what did we use for that one? That was the same side interior angles converse was used to make that statement. The last problem, we're using algebra to find the value of x for which A would be parallel to B. Once again, same type thing. You look and see, based on these angles, which line is the transversal. This would be the transversal. What kind of angles are the two angles that are labeled? They are same side interior. So since they're same side interior, in order for A to be parallel to B, those two angles would have to be supplementary, according to the same side interior's converse. So in order for them to be parallel, they have to be supplementary, so they would have to equal 180. So set the two angles. You have 3x plus 3 plus 48 equal to 180. And then solve for x. So we have 3x plus 51 is 180. Subtract the 51 from both sides. You have 3x equals 1, what's that, 51? It's a 9, 2, it's 129. And then divide both sides by 3, and x is 43. So the value of x for which A is parallel to B, x would have to be 43 in order for that to be true, in order for them to be parallel, and those to be same side interior angles that are supplementary.